Well, it feels kind of wrong to talk about malnutrition after this lunch, but I will try. So, I think all of us can relate to the problem of malnutrition or starvation or hunger in one way or another. Luckily for many of us, it's in the past, something in our family history. As you can see on this figure, us humans gotten taller during the last century mostly because of the improved nutrition. Another example I wanted to share with you, it's from my family history, and it goes all the way back to the Great Russian Famine, that we call it, that killed 5 million people and many children among them. It happened in early 1920s, and in the south of Russia. And my maternal grandfather happened to be born there and then. So of the 12 siblings, only 5 survived this event. And all 5 of them developed all kinds of serious diseases relatively early in life. And those included heart diseases, diabetes, and asthma that were not very common back then. So it definitely shows you the impact of malnutrition in childhood. And of course, many of us as parents, if you can see it, can imagine the pain of looking at your baby or child like this in this horrible condition and realizing that it's not some super bug or weird genetic disorder or incurable disease that is slowly killing them, but it's just simple lack of food. And it's as little as 1 cup full of food a day that could save their lives and keep them relatively healthy. They probably would be still hungry, but not in danger. This world shows you the distribution of world's hunger, and you can see the areas shown in orange and red. That's where the problem is most severe. And yearly, about 17 million children are affected by malnutrition. And severe acute malnutrition means it's life-threatening malnutrition. So 2.6 million of these children die every year, and it means 1 child dies every 12 seconds. The numbers are huge. So looking at India, for example, where the malnutrition severity is just moderately high, with a population of 1.2 billion and 39% of children, 500,000 of children dies only in India each year because of malnutrition, and another 60% of children are stunted or underweight. It's stunning 280 million of children that do not grow to their full potential just because of lack of food. So malnutrition is associated with 2 major clinical conditions. One is called marasmus, and it is just simply insufficiency of any food or calorie malnutrition. It is manifested by severe stunting and wasting. And as bad as it looks, biologically, it is considered to be a successful adaptation to malnutrition, which is achieved by degrading all nutrient storage, protein, glucose, and everything being catabolized to provide energy for the vital function of brain and other organs. And this condition can be seen in starving children and adults, which is not the case in kwashiorkor, another type of malnutrition, which is mostly caused by the lack of protein in the diet. And it is also manifested by wasting and stunting that may or may not be as severe as in marasmic children. But the central syndrome here is generalized swelling and liquid accumulation in the belly area that is called edema. And unfortunately, in this condition, because of lack of the protein breakdown pathway is affected. And because of that, these children cannot adapt to the malnutrition. And because of that, again, many physiological processes in them become pathologically affected, and this condition is extremely hard to intervene. So in malnourished children in developing countries, there are 2 major contributors to something that is recognized as a vicious cycle of malnutrition and enteric disease or enteric dysfunction. It's the lack of nutrients and quite often it's lack of protein or generally nutrients, and lack of hygiene, and environmental contamination and contamination of water sources with pathogens. So as soon as protein malnutrition starts, it affects immunity and damages the gut barrier, because these two are highly dependent on protein availability. Impaired immune function contributes to chronic diarrheal disease. Chronic diarrheal disease causes more gut damage. Damaged and inflamed gut results in malabsorption, which aggravates malnutrition. And so something that started as a lack of nutrients becomes also a secondary malnutrition and different micronutrient deficiencies. Besides anatomical gut structures, there are also two important organs or systems in your gut. It's the majority of immune system is located in your gut, and the microbiome. These two become immediately affected by malnutrition. Another negative effect of malnutrition, this compromises the brain development and activity, because together with lack of macronutrients, the things, for example, like essential amino acids that our body cannot synthesize, they become decreased. And for example, tryptophan is critical for brain development and function. So what's being done? There are global humanitarian initiatives that are abbreviated as WASH and SHINE, and they're focused on improvement hygiene standards for water sources and providing adequate nutrient to infants and children. There is also research going on identification top pathogens associated with childhood stunting and developing pathogen-specific antimicrobials. So ready-to-use therapeutic foods are a big part of these trials, and those are great foods because they're based on peanut butter. They have dry milk added and minerals and vitamins. They can be stored for very long periods of time, even in hot weather, and they do not need to be reconstituted with water, which allows to avoid additional exposure to environmental pathogens. So the aspiration in these trials is that a change in the diet early enough can result in full recovery. However, the reality is more complex because, number one, nobody knows what is this early enough, the magical time point. Number two, there are always children for whom the intervention could not be started early enough. And number three, while often these interventions allow to prevent death, but they do not restore children's health. And this is why we need more research using translational models. Swine provides one such model because of numerous similarities we're sharing with pigs in our anatomy, physiology, immunology, and specifically in gastrointestinal physiology and diets. In my research, I use neonatal gnotobiotic pigs as a model of protein malnutrition. Gnotobiotic animals are derived via C-section, sterilely, and because of that, they're devoid of any commensal microbiota. Instead, we can reconstitute them with a complete human infant microbiome to increase its translational potential. And we place them on protein-deficient diets and infect them with human rotavirus to mimic intestinal insults commonly seen in malnourished children. And in this model, we study different dietary interventions, including probiotics and essential amino acids. So the first exciting observation in that model was that it became the first model that actually reproduced kwashiorkor edema, or that generalized swelling. You can see it on this picture. And it's very similar to that seen in children. And it was not reproduced in other animal models before. So as expected, protein-deficient piglets became stunted and underweight. And they also had disrupted intestinal barrier, decreased immune function. They had increased severity of rotavirus disease, altered amino acid metabolism, and altered biochemical blood parameters. So all the signs and symptoms observed in malnourished children. Another very exciting finding we got with this model was that once intestinal microbiome becomes conditioned by protein deficiency and then transplanted to a new subset of piglets on a sufficient diet, piglets that never were exposed to malnutrition, these piglets are not able to grow as efficient as their litter mates that have sufficient microbiomes, which means that the microbiome becomes dysbiotic or altered and plays a pathological role in these piglets. So why this is important? Because protein deficient adults, including pregnant women, do not develop kwashiorkor. This condition is only seen in children. But they do develop intestinal dysbiosis, and that dysbiotic microbiome is being transferred to their babies, and that predisposes them to higher severity of childhood malnutrition and other health defects. In our interventional trials in this model, we saw the major thing that no single intervention can be efficient. Rather, you have to target each component of this vicious cycle to successfully intervene. You need to provide nutrients. You need to provide essential microelements. You need to downregulate intestinal inflammation and possibly use specific antimicrobial treatments. It's like domino effect. Once you initiated the chain reaction by knocking the first domino down, it's not enough just to pick the first one up again to rebuild the whole chain. It has to be done for each component. So with this model, we can generate urgently needed information to identify efficient treatments, optimal timings for these treatments, and to address the issue of maternal malnutrition that is being almost completely disregarded right now in all interventional trials. And this allows malnutrition to perpetuate in generations. In conclusion, I wanted to remind you of these numbers. Almost 3 million children die of hunger every year, which means 50 children just died during my talk. These numbers are huge. The problem is still huge, and it should not be acceptable anymore. So we need to bring our science, education, and humanitarian efforts all together so we not only can save these children's lives, but also restore their health so they can become who they should become, and so they can join the fight against the malnutrition and poverty in their countries. Thank you.